With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us solve this question. The question says that if K1 and K2 are the respective equilibrium constants for two reactions, XeF6 gas plus H2O gives XeOF4 gas and 2HF gas. XeO4 gas plus XeF6 gas gives XeOF4 gas and XeO3F2 gas. The equilibrium constant for the reaction XeO4 gas plus 2HF gas gives XeO3F2 gas plus H2O gas will be. Here four options are given. Option A, K1 by K2 square. Option B, K1 into K2. Option C, K1 by K2, and option D, K2 by K1. So in this question, two reactions are given, and for these two reaction equilibrium constant are K1 and K2. Then third reaction is given and we have to find out the equilibrium constant for this third reaction in terms of K1 and K2, and four options are given. So first reaction we have XeF6. It reacts with water to form XeOF4 and 2HF. Now the equilibrium constant for this reaction is K1. Now we will write the expression for the equilibrium constant K1. Now for writing the expression for equilibrium constant, in numerator we have to take the product of the concentrations of products and divided by the product of the concentration of reactants. So in products we have XeOF4 and 2HF. So here we will be having XeOF4, concentration of XeOF4 into concentration of HF raised to the power 2. Now because here we have 2 moles of HF and stoichiometric coefficient is always written in power of the concentration term, divided by, we will take concentration of reactants. So in reactants we have XeF6, so concentration of XeF6 into concentration of H2O. So this is K1, right? So let this be equation 1. Now we have second reaction XeO4 plus XeF6 combines to give XeOF4 and XeO3F2. Now for this reaction equilibrium constant is given K2. Now when we write the expression for K2, it will be equal to concentration of products. So we have concentration of XeF4 into concentration of XeO3F2 divided by concentration of XeO4 into concentration of XeF6. So this is the expression for K2. Let this be expression 2. Now we have third reaction, that is XeO4 plus 2HF reacts to give XeO3F2 plus H2O. Let equilibrium constant for this reaction is K3. So the expression for K3 will be equal to concentration of XeO3F2 into concentration of H2O, as these are products, divided by concentration of reactants XeO4 into concentration of HF raised to the power 2, as 2 is the stoichiometric coefficient of the reactant HF. Now this is the expression for K3, but we need equilibrium constant in terms of K1 and K2. So what we will do, we will arrange these concentration terms in such a way that we get K1 and K2. So what we can do, K3 is equal to XeO4 HCO3F2 into concentration of H2O divided by concentration of XeO4 into concentration of HF raised to the power 2. So let us multiply this by XeOF4 and divide it by the same term, concentration of XeOF4. Also, let multiply this by concentration term XeF6 and divide it 2 by XeF6. Right, we can do this. Now, we can arrange it like this. Concentration of XeO3F2 into concentration of XeOF4, it is taken here, divided by XeO4 into concentration of XeF6 into concentration of XeF6 into concentration of H2O divided by concentration of XeOF4 into concentration of HF raised to the power 2. Right, we can write it like this in two groups. Now, from here, K3 will be equal to, now if you look this first term, it is equal to K2. As you can see, this is equal to K2. So this term is K2 into, if you look this second term, and compare with K1, then you will realize that this is 1 by K1. This is basically reverse of K1, right? So overall answer that we will get from here is K3 is equal to K2 by K1. Right, so this is the equilibrium constant of the reaction in terms of K2 and K1. So the final relation that we want here is K2 by K1. So from here the answer of the question will be option D, K2 by K1. So option D is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.